Today I'll start with, today I'm going to explain the n queens problem, which is a very famous and well-known problem. This is classified as hard in LeetCode. So the problem is basically you'll have some queens, you'll have n cross n board, and you'll have n queens, and you have to place the queens so that they don't attack each other. So the queens can generally in a chessboard attack either vertically, horizontally, or diagonally. So that's how a queen moves and attacks. So in this video, I'll have a more faster approach of kind of explaining the code. I'll directly start with the code, and I will explain on a drawing board whenever I need, whenever I feel like I need to explain. So okay, so our main function will be a queen solver, n queen solver. Okay, so what variables does it take in it? Takes a variable called board, which is a vector of string. So how does it define? So if you look at a board, we can define this as a string, right? So for example, this is, so if it is a 4 cross 4 board, so that means that here nothing is placed and here a queen is placed. So this is essentially a string, right? It is essentially a string. We have to use strings for every rows, and hence it is board is basically a vector of strings. And now comes the second variable, which is the answer. Now answer is a vector of strings, so it is an amalgamation of vector strings. A vector string is a board, so answer contains all possible board configurations which are valid, and that's why it is vector of vector strings, since vector string is a board. Hopefully this answers your doubt. And then and then obviously we have row as input and then n as input. So this is the current row under consideration, and this is n means the grid, right? Grid size n cross n, which is always will be a square grid. So this is actually the helper function, n queen solver. The main function which is defined in LeetCode is solve n queens. So so le- uh, so okay, next we'll try to reframe the question. So the original question is, okay, you need to place queens such that no none of the queens attack each other. The way to reframe this question is, you can place queens in each row, find the optimal places of queens in each row, such that such that when you are done placing the queens in all of the rows, then you have a valid configuration in which none of the queens attack one another, right? So that is the way to reframe a problem. uh, that makes it simpler. Now we only have to focus queens, uh, find the best position for a queen in a particular row and then move on, right? So yeah, that's that. And then basically we define our answer as an empty vector of vector strings, because we don't have anything in the to put in the answer yet. As and when we find a valid configuration, we'll push that board into the answer. And then we initially will initialize the board, which is basically a uh, we basically at every position of the board will have dot, which means nothing has been placed, which makes sense. And then we have that n queen solver, whose inputs I've already explained before. Now let us look at what happens in the n queen solver. This is a termination condition. I'll come to this later. And now there is something called we'll basically going through each column in the particular row, and then trying to place a queen there and see that if we can if we can reach a solution, right? So what happens, we are first, before placing the queen, we are uh, using this is safe function to check that either whether we can place the queen here, because that will depend on what queens have been placed in the board in the previous rows, right? So let us have a quick look at the is safe function. It's pretty simple. So we have a row and column as input, and the board size, and as well as the board configuration till now. And then we check in the previous rows, right? For the previous rows, in this particular column, has any queue occurred? Vertical check. So that means, like, if you're trying to place a queen there, we'll check here in this position what has happened, right? We also need to check here, which is the left diagonal, and then you have to also check this side, which is the right diagonal. So how do we do that? So in the left diagonal, we basically, our rows and columns are getting decreased by one with every step. and then for the right diagonal, our row is getting decreased, but our column is getting increased by one. That reflects in the code. As you can see, for the left diagonal check, both our rows and columns are decreasing. Obviously, we'll move till we can find a valid index, right? And then we'll start with row minus one and column minus one, because row and column is where we are checking. So obviously, we have to start from here, right? From here, if you're checking here, you have to start from here. And then whenever we find that we have a queue already in place, then we return false immediately. Same for the diagonal check. Here the j increases, as I already mentioned, and uh, j will start with column plus one, because j is gonna start from here, and this is the column plus one, but row minus one. So yeah, and then again, whenever we find that a particular index on the right diagonal has already queen placed, right? And then we obviously return as false. And then we can't, if we can't find all these unfavorable scenarios, then we have to pass through. So that's about the isSafe function. And then once we feel that okay, now placing the queen here is safe, we'll place the queen here, and then recursively call the n queen solver, right? And then hopefully we'll be able to place all the queens till row n minus 1. So that means we'll be reaching at row equal to n. So this is the final condition. So we'll be reaching row equal to n when we have placed all the queens from row equal to 0 to row equal to n minus 1. That means we have placed n queens. So then after that we'll come to row equal to n, and then obviously this is a valid configuration. That's why we are pushing that into the answer. So that explains this base condition, which I told earlier that I would explain later, and now I have explained this. Okay, so then after that, so either using this call will ultimately recursively push a valid configuration into an answer, or will not be able to push it, and then it will break down in between, because somewhere because where it will break down is uh, will basically enter a condition in which will be returning this not this will not this is safe will not be true. Then we'll move forward, and then maybe in some scenario will not be able to will not be able to assign we'll not be able to recursively call the below solver, because we were not able to find a valid configuration here. So that means for that particular part, nothing will be captured. For example, what I'm trying to say is, suppose here we are here currently, and or is not a good place. We are here currently, and then we are basically going to the next row and trying to find a valid configuration. Nowhere we could place this next queen. That means if that means each safe is never satisfied. So this entire loop will cross, and nothing basically will happen, and this function will do nothing. So basically this call which is coming from here will result into nothing. So basically that means that this path is not useful, and hence nothing is happening, which makes sense, right? So that's how only valid configurations will be captured. If if subsequently after placing the queen here, we can get something, we can get a valid configuration. So that will be already be captured here. Either we get a valid configuration, or we basically one of the recursive calls in the call tree will result into nothing, and then that will mean that nothing gets pushed into the answer. And then we need to reset this, because okay, now we place the queen here, get an answer, or don't get an answer, but there can be other answers which can be found in by placing the queen in the subsequent columns of this particular row. So that's why we need to reset that, and reset this particular row column index of the board. So that we do, and then try to for in this loop, try to look at other columns for the particular with the same row, and see that if we can have any other valid answers, or see that if we can capture any other valid answers. So hopefully this explains the problem. I'm sorry, I think I stammered a bit in between, but I think you got the basic idea of how it is and how it's getting solved. So yeah, this is a very famous problem, and this is classified as hard, but the idea is not that hard. But I think if you're given this problem in a particular I mean, in particular interview, then you will be able to come up with an answer, and it doesn't take too much effort to really remember the solution or understand the solution or record the solution. In all those three cases, I think it takes minimum effort, because this the I mean overall idea is pretty simplistic. Basically, try for every column of the particular row and then move the rows forward and capture valid configurations whenever possible, right? So I think you're able to understand this video. If you're not able to understand this video, please rewind and have a rewatch, and then I'm pretty sure that you'll be able to understand this. I'll see you in the next video. Thank you. Bye.